Hello and welcome to Honors Function. This is the second lecture on quadratic equations, and in this video we're going to learn to quickly plot precisely the graph of a quadratic equation. Let's start. To understand how one goes about graphing a quadratic equation, I will look first at the simplest of all quadratic equations, y equals x squared. Let's graph this. So in this case, I am going to plot some points. Y equals x squared. So if x is 1, y is 1. If x is negative 1, y is 1. If x is 2, y is 4. If x is negative 2, y is 4. 3, 9 and negative 9, and finally 4, 16 and 16 right here. And here is, and of course 0, 0. Here is my parabola. Please make sure the nose of the parabola, or rather the vertex, is round. Okay, I don't want to see any pointy nose right here. No pointy nose right there. All right. Anyway, what we notice here is, instead of talking about coordinate of point, let's talk about distance from the vertex. If you move 1 away from the vertex in any direction, you'll go up 1. Okay. If you move 2 away from the vertex, you'll go up 4. If you move 3 away, you'll go up 9. And 4 away, and you'll go up 16. In any direction, if you move 4 away from the vertex on the left, you will still go up 16 units. Okay, so there's a slight shift in language. Instead of saying at negative 2 the output is 4, I'm gonna say if I move 2 away from the vertex in either directions, I will go up 4 units. Okay. All right, now let's look at another type of equation. For example, y equals, let's take 2x squared. So what's going on here? Well, first you do x squared and then you multiply by 2. So check it out. If I move 1 away from the vertex, 1 squared is 1 times 2, 2. If I move 2 away, 2 squared, 4 times 2, 8, right here. 3 away, 3 squared 9 times 2, 18, right here. And I'm plotting behavior, and of course, symmetrical with respect to the axis of symmetry. So I'm going on the other side, right there. And here is 2x squared, okay? Here is 2x squared. How, and you can do that with so many different kind of coefficient. How would you do 1/2? So I'm going to do this one in blue. How would you do 1/2 of x squared? Well, you're going to take these x squared and you're going to divide them in 2. I'm going to erase all of these arrows here. Okay, so 1/2. Here we go. 2, 4 divided by 2, 2. 2 squared 4 divided by 2, 2. 3 squared 9 divided by 2, 4.5. So that was 2 right here, right? So 2, 3, 4.5 right there. Okay, let me get the points on the other side too. So this was 2, this was 4.5. Okay, 4, 16 divided by 2, 8. So that was 4.5. So 5, 6, 7, 8 right here. All right, let's keep on going. 5, 25 divided by 2, 12.5, 8, 9, 10, 11, 12.5, right here. Okay? So you see, I'm just right here plotting a behavior. It's exactly what you do with an equation of a line when you have like mx plus b, right? For example, 2/3 of x plus 3, you go to the y-intercept and then you plot, you follow the line. Okay, so from the y-intercept like 3, and then you do 3 run, 2 rise, 3 run, 2 rise, right? It's exactly the same thing, except that this time is for a parabola, so it's not a line like that, but I'm plotting a behavior. So we have a result now that will allow us to use this kind of technique for any parabola. Let's go over the result. Here we go. The graph of this parabola right here is a translation of the graph of this one, so just ax squared, where the vertex moved from 0, 0 to hk. So you move the vertex from 0, 0 to hk, but the behavior is exactly the same as ax squared, okay? Same type of behavior. And I'm going over an example right here. For example, you see, this is 1/2 of x squared, and this is 1/2 of x squared minus 3x plus 1. Well, okay, but the behavior of the two parabola right here, the way this one opens and this one opens is exactly the same, okay? You just take the black one and you move it 3 units to the right and 3.5 units down, okay? All right, let's now go over the first example. All right, I'll do number 1 and you will do number 2, okay? So I need to graph this parabola. I am not going to plot any particular points. I mean, I'm going to plot a lot of points, but I'm not going to put some x's and figure out the y's. This is not how we do it. The first thing you want to do is you want to complete your squares. So y equals x squared minus 6x plus 1. My leading coefficient is 1. Great. I can just complete my square right away. So it's x minus 3 squared. Minus 9 plus 1 is minus 8. Okay, I went directly. And therefore, my vertex is 3, negative 8. Be careful of your sign when you read the vertex, okay? Here, let's write the y coordinate. It's right there, right? When x is 0, you have 0, 1. Okay, for the discriminant, I don't know. Let's start plotting point. So I said the vertex is 3, negative 8. 3, negative 8, right here. Now, look, the parabola behaves exactly the same as y equals ax squared. So here it's x squared. And I know the behavior of this one. 1, 1, 2, 4, 3, 9, 4, 16. And the first numbers represent the distance from the vertex. So 1, 1. Here we go, on either side. 2, 4. 2, 4. So right here, on either side. So 3, 9. So that was 4 right here, right? So 5, 6, 7, 8, 9. Here we go. 3, 9. And that should be my y-intercept. Is my y-intercept 1? Yep, it is. Okay, that was 3, 9. I was 9 up. The next one is for 16. So 9, 10, 11, 12, 13, 14, 15, 16. Here we go. You see, I have some very precise points, and I have not plugged in a single x value into the equation to graph this point. Right here. And I am not using either my x-intercept or y-intercept because these would be actually irrational numbers. Okay? Let's check out their values. Here we go. Here's my parabola. So please, again, make sure you don't do a pointy nose right here. All right? All right, let's continue and finish this question. Discriminant of this parabola, b squared minus 4ac, so 36 minus 4 times 1 times 1, so it is 32. That's my discriminant. It's positive, so I will have 2 x-intercept. How do you find the x-intercept? I'm not going to use the b squared minus 4ac, the quadratic formula. I'm just going to pick them up from here. So for my x-intercept, I'm just going to say x minus 3 squared minus 8 equals 0. So you move that there and you remove the square. So you have x minus 3 equals plus or minus square root of 8, which is plus or minus 2 root 2. And so the x-intercept, here x is 3 plus or minus 2 root 2. Careful when you write the x-intercept, it has to be point. So 3 plus or minus 2 root 2, 0. And this is what it means. Look, you go at 3 right here, and you add 2 root 2, right? So you remember root 2 is about 1.4, so I should be adding about 2.8. And this is exactly what happened. 2.8, and then 3 minus 2.8, right there, okay? This is plus 2 root 2, and this is minus 2 root 2. So we're doing a pretty good job at graphing this parabola. Axis of symmetry right there, right? It's x equals negative 8. And then the range, well, the range, here's my my y coordinate of the vertex, and without looking at the graph, okay? I am not looking at the graph right now. I shouldn't have crossed it. I'm not looking at the graph, but the parabola open upwards. Therefore, this is the lowest point. So my range is going to be, I'm going to start at negative 8, and I'm going to go on forever at positive infinity. Okay? I hope this is clear. I want to do actually a second example. This one is taken from the class work that you have to do. I believe it's number 5. Okay, so I'm going to do this one. There are several in this class work. I think you have 10 equations, so I'm going to tackle one right for you. Okay, so you can see right here we have a negative 0.5. This is not a big deal. Let's find the vertex form. So negative 0.5 means negative 1/2, right? Okay, so what you want to do, the first thing is you want to multiply both sides by negative 2. So negative 2 times f of x equals, so x squared, here's my leading coefficient of 1, plus 6x plus 17. Okay, now let's complete the square here. So that's x plus 3 squared minus 9 plus 17. So it is x plus 3 squared plus 8. Okay, so now let's go back to f of x. F of x equals negative 1/2 times x plus 3 squared minus 4. Here we go. So now I should be able to graph this parabola. So my vertex is negative 3, negative 4. So let me write it. The vertex is negative 3, negative 4, right there. I'll plot it right now. Negative 3, negative 4 right here. And the parabola is concave down, right? Okay, so we can answer a lot of things here. X-intercept, you're not going to have any. If the vertex is right here and you're concave down, you're not going to have any x-intercept. Discriminant, well, I'm not going to compute it. I know it's going to be negative, right? It is negative. Y-intercept, right there. So it is 0, negative 8.5. All right. Let me look at my axis of symmetry. So it's right here. X equals negative 3. X equals negative 3. And the range, the parabola opens down. That's going to be the highest point. So you start at negative infinity and you end up at negative. Wait, what's the highest point? Oh, not this one right here. Sorry. I meant this one right here, the y coordinate of the vertex. Okay. So negative 4. Here we go. Now let's graph this one, and you will see there are a lot of points there, but that's how I expect you to graph it, okay? So I'm graphing the behavior 1/2 of x squared, but this time I go down, okay? So 1, 1/2. Okay, 1 squared is 1 divided by 2, 1/2. 2 squared, 4 divided by 2, 2. So 2, 2. Here we go. 3, so 3 squared, 9 divided by 2, 4.5. So 2, 3, 4.5. Here we go. And look, we got our y-intercept here, right? Okay, good. That was 3. 4 squared, 16 divided by 2, 8. So 4.5, 5, 6, 7, 8. Right here. Move 1, move 1. All right, that was 8 down, and we were at 4. 5, 25, 12.5, 8, 9, 10, 11, 12.5. Here we go. See, it's really precise here, right? That was 5, 6, 36, 18, 12.5. So 13, 14, 15, 16, 17, 18. Last point. Did you see that? This is really pretty simple, and it is very accurate. Here is the parabola you were looking for. This is a beautiful branch right here. Let me try to do another beautiful branch on the other side. Not sure I'm gonna succeed. Hey, oop, yeah, I missed the point right here. Here we go. All right. So, well, what about if you don't have some nice coefficient like, you know, 2 or 1 or 1/2, you know? What about if it's like 3x squared? Well, this is easy, right? You take x squared, you multiply by 3. Well, what about if it is like 1/3 of x squared. Well, you have a classwork on this one, so here it's not going to be as nice. I'm not going to take 1, right? Because if x is 1, you're going to have 1/3. That's not nice. 2, not practical. 4/3, but 3. Now 3 is going to work, right? Because 3 squared is 9, divided by 3 is 3. Now that's a nice one. Which one is going to work after that? You see, it's going to have to be the multiples of 3. 6, right? 6 squared is 36, divided by 3, 12. So you can get some really nice points, even when the coefficients are a little bit messy. Thank you for watching.